welcome to AMIRS Math School. In this video, we are going to learn how to find the area of various types of triangle. And we know a triangle is a plane figure bounded by three straight lines. Here, this one is the triangle and this one is the vertex. If we say this vertex is A, then opposite of this vertex, this side length is A. And opposite of this vertex B, the side length is B. And opposite of this vertex, that is C, the side length is C. And this angle is C angle, a B angle, and the angle A. Now this one is the height of this triangle. Suppose this one is H. We know the types of triangle are classified according to their sides and the angles. According to the sides, classification of triangles are: number 1, equilateral triangle. When all three sides are equal for any triangle, that triangle is called equilateral triangle. Number 2, isosceles triangle. When any two sides of any triangle are equal, in that case, that triangle is called isosceles triangle. Number 3, the scalene triangle. When no sides are equal, that is, each of the sides have the different length, in that case, that triangle is called scalene triangle. And according to the angles, the classification are: number 1, the acute angle triangle. When all three angles of any triangle are acute, that is the less than 90 degree, that triangle is called acute angle triangle. Number 2, obtuse angle triangle. When any of the angle of any triangle are greater than 90, that is obtuse, that triangle is called obtuse angle triangle. When any angle is right angle, that is the value is exactly 90 degree, that triangle is called right angle triangle. And number 4, which is very much similar to this equilateral triangle. This equilateral triangle we can also call equiangular triangle, because in case of equilateral triangle, three sides are equal, also three angles are equal. That's why we can call this one as a equiangular triangle. The main aim of this video is to find the area of all types of triangle using the side and angle in the all possible way. And the very basic way to find the area of the triangle is area equal to half time base time height. And we use this formula to find the other formula for the finding the area of the various types of triangle. Let's start with area of the equilateral triangle. Suppose this one is the equilateral triangle. For the equilateral triangle, we know all three sides are equal. Suppose the length of side is A, and this one is the height, this one is the H. And this one is also the median of this triangle. And in case of median, this median is split this side BC into two equal parts. So if this length is A, so the half length is A by 2. This half length is also A by 2. We know the area of the triangle is half time base time height. If we consider this A is the base and this H is the height, let's find the value of this height H in terms of A. In this triangle, this right angle triangle, according to Pythagoras theorem, we can write A square equal to H square plus A by 2 whole square. That is, the hypotenuse square is equal to the sum of the square on the other two sides. That is H square plus A by 2 whole square. We are going to find the value of H. So here we can write H square equal to A square minus A square by 4. After simplification, we can write H square equal to 3A square divided by 4, or H is equal to square root of 3 by 2A. So, in case of equilateral triangle where the side length is A, in that case, the value of height of that triangle will be square root of 3 by 2A. So, this is our height. And if we substitute the value of the base is A and the value of the height H is equal to square root of 3 by 2A in this formula, that is, half time base is equal to A and height is square root of 3 by 2A, that case we will get the value, that is area is equal to square root of 3 by 4A square. This is the formula to find the value of the equilateral triangle when any side are given. Since all three sides are equal, so if the length of side is A, then the area of the equilateral triangle is square root of 3 by 4A square. And in case of equilateral triangle, this height is also the median of this triangle. For this triangle, we get three heights, and all three heights are equal to the median. So, in case of equilateral triangle, the height and medians are equal. So, the value of median in case of equilateral triangle is also square root of 3 by 2A. Let's find the area of the isosceles triangle. Here, this ABC is an isosceles triangle. These two sides are equal. That is, the length is A, and this side length is B, and this one is the height. For the isosceles triangle, this height and this median is equal. With this height, this length is separated into two equal parts. So this part is B by 2, this part is also B by 2. And the area of the triangle we know half time base time height. And we are going to find the value of this A in terms of this A and this B by 2. Now we need to find the value of AC in terms of A and B. In this triangle, this right angle triangle, we can write A square equal to AC square plus B by 2 whole square. That is according to the Pythagoras theorem. So AC square equal to A square minus B by 4, and the AC square equal to 4A square minus B square by 4, and the A is equal to square root of 4A square minus B square divided by 2. So this is the value of height of an isosceles triangle when the equal side lengths are A and other side is B. So this is our height. In this case, the base is B. So substitute the value of base and the height in this equation. We get half times B times square root of 4A square minus B square divided by 2, which is equal B by 4 square root of 4A square minus B square. So this is our formula to find the area of the isosceles triangle when the side length of this isosceles triangle is A and B. A is the length of equal side and B is the other side. In this case, all the heights and medians are not equal. Very special case, this one median and one height is equal. So in this way, we can find the value of height and the area of the isosceles triangle when the equal side length and other side length are given. Now, the area of the acute angle triangle. In case of acute angle triangle, all three angles are less than 90 degrees. That is, all three angles are acute. So this one is the acute angle triangle. That is A, B, C, and this one is the height. Now, we know the area of the triangle is half time base time height. We want to find the value of this A in terms of this B and this angle. That is, in terms of one angle and one side. In triangle A, B, D, we can write the A is by C is equal to sine B. That is, the perpendicular divided by the hypotenuse is equal to sine B. From here, we can write A is equal to C sine B. So we got the value of height A. So height of this acute angle triangle A is equal to C sine B. If we substitute this height and this base in this equation, we have the area equal to half time the base is A and the height is C sine B. So the area is half AC sine B. These two sides, A and C, and sine B, that is the included angle between these two sides. So this is the area of the triangle. That is, the area is AC sine B. For this acute angle triangle, we can express this height using this side, also this side. So in that case, we can get the area that is half AB sine C. So when these two sides, then the angle included these two sides. That is half AB sine C. These two sides and the sine of the angle between these two sides. And this one is also the formula to find the area. And the other formula is half BC sine A. BC sine A. This one is another way to find the area of the acute angle triangle. If two sides of any triangle and the angle between that two sides of that triangle is given, we can find the area of the triangle using these three formula. Also, we can find the height using this formula. Now, the area of the obtuse angle triangle. When any one angle of any triangle is greater than 90 degrees, that is obtuse, in that case, that triangle is called obtuse angle triangle. So you see here an obtuse angle triangle since this C angle is obtuse, greater than 90 degrees. In this case, if we extend this side up to D and join with this A, this one will be the height of this triangle. We know the area is half time base time height, and we are going to express this height in terms of this side. So in triangle ADC, we can write the A is by B is equal to sine 180 minus C. That is, if this value is C and this one is one straight angle, so this value is 180 minus C. So A is by B is equal to sine 180 minus C. So A is equal to B sine C. Since the sine 180 minus C, this value is again sine C. So the value of A is B sine C. So this is the height of this triangle. And the base of this triangle is A. So substitute the height and the base in this equation. We have half time A times B sine C. So the area of this triangle is half AB sine C. Very much similar to the previous one, that is acute angle triangle. So this is the formula to find the area of the obtuse angle triangle. And also we can use these two formula also, that is half AC sine B and also half BC sine A. These two formula, very much similar to the acute angle triangle. Now the area of the right angle triangle. We know in case of right angle triangle, one angle is 90 degrees, this one. This angle is 90. So in this case, these two sides, that is the side A and side B, that is other than the hypotenuse, these two sides are, if one is base, another one is the height. So the multiplication of these two value and multiplying with half, that will be the area of this triangle. That is half time base time height. So the area is half time base time height. The value of base is A and the value of height is B. If B is the base, in that case A is the height. So half time AB. So this is the formula of right angle triangle half AB. This A and B is the side length other than the hypotenuse. So this is the formula to find the area. We can also use this formula, that is area equal to half AC sine B. Also the area equal to half BC sine A for this angle. Multiplication of these two value and the sine of this included angle A times half. This one is also the area. And in case of this angle C, that is the area is half AB sine C, we know this angle is 90 degree, that is half AB sine 90 degree, and the value of sine 90 degree is equal to 1. In that case, we get this value, that is half AB. Now, the angle side relation in case of triangle. This one is the triangle. Here, A, B, C, and three side length, that is A, B, C. Now, when these three side lengths are given, we can find the value of any of this angle using this formula, that is cos A equal to B square plus C square minus A square divided by 2BC, or cos B equal to C square plus A square minus B square by 2AC, or cos C equal to A square plus B square minus C square by 2AB. Using any of these three formula, we can find any of this angle. And using the inverse trigonometric function, that is, we can find the value of this angle, that is A is equal to cos inverse B square plus C square minus A square by 2BC. That is this value. Cos inverse this value will give the value of the angle A. Similarly, cos inverse this value will give the value of the angle B, and cos inverse this value will give the value of the angle C. If we find the value of this angle, then we can easily use the previous formula to find the area of this triangle. That is, using this formula, that is area equal to half times AC sine B plus half BC sine A plus half AB sine C. If this three side A, B, C is given, and using this formula, if we find the angle A, angle B, or angle C and substitute the value here in this formula, we can easily find the area of the triangle. Now, the area of scalene triangle. This one is very much important because this formula, which is known as Heron's formula, which is applicable for all types of triangle. If you know this formula, you can find the area of any type of triangle when three side lengths are given. For the scalene triangle, where three side lengths are different, that is, no sides are equal, in that case, we have to first find the value of S, that is A plus B plus C divided by 2, half perimeter. The sum of three sides divided by 2. This one is indicated with S. In that case, the value of area is equal to S times S minus A, S minus B, S minus C. First, any side is subtracted from this half perimeter. Then the second side is subtracted from the half perimeter, and the third side is also subtracted from the half perimeter. Then multiplying all these three values with this half perimeter, and square root of this multiplication value will give the area of this triangle. So this is the formula to find the area of the scalene triangle. That is, when three side lengths are given, we can easily use the formula to find the area of the triangle. So how we get this formula? Using this formula, that is sine A by 2 is equal to square root of S minus B times S minus C divided by BC, and cos A by 2 is equal to S times S minus A divided by BC. We know what is S. S is half perimeter. We know the formula is area equal to half BC sine A. That is, we can use any formula, any of these three. We just take for this angle A. So the area of the triangle using this angle and these two sides, that will be half BC sine A. So this sine A, if we write as half time BC sine 2 times A by 2, 2 sine A by 2 cos A by 2. That is, the formula of sine 2A is 2 sine A cos A. Now substitute the value of sine A by 2 and cos A by 2 from here. We can write the area is equal to half time BC 2 times square root of S minus B times S minus C divided by BC times square root of S times S minus A divided by BC. After simplifying this line, we can write the area is equal to square root of s times s minus a times s minus b times s minus c. So using this Heron's formula, we can easily find the area of the scalene triangle. Now the special case of the Heron's formula, that is the area of the scalene triangle. This one is the scalene triangle. Now area is equal to 1 by 4 times square root of 2a square b square plus 2b square c square plus 2c square a square minus a to the power 4 minus b to the power 4 minus c, where the a, b, c are the three side lengths of the triangle. So this one will also give the area of this scalene triangle. This formula is the simplified form of the Heron's formula, and we can use this formula also when three side lengths are given. Now let's see the area of the triangle and the circumradius relationship. If we draw three perpendicular on the three midpoint of sides of triangle, then this meeting point is called the circumcenter. From this circumcenter to any vertex length is the circumradius. So this one is the circumradius. Also this one, also this one. And if we draw one circle with this radius and taking this point as a center, that is called the circumcircle. So in case of the area of the triangle and this circumradius relation, we can write the area equal to ABC divided by 4R, where ABC are three side length and this R is the circumradius. So the area of the triangle ABC is equal to the length A times B times C divided by 4 times the circumradius. So when the three side length is given and the circumradius is also given, we can easily find the area of the triangle using this formula. Now let's see the area of the triangle and the Inradius relationship. The in-center for any triangle is the intersecting point of three bisector of the angles of any triangle. So if this line, and this line, three line are the bisector of these three angles, and this one is the intersecting point, so this point is called the in-center for this triangle. The perpendicular length from this point of any side is the Inradius, that is this one. And if we draw one circle with this radius, that circle is called in circle, which touches all three sides of triangle. So this length is Inradius. We can write the area of the triangle is equal to half time A plus B plus C times the Inradius, where A, B, C are three side length of any triangle. That is, the area of the triangle is half times A plus B plus C times the Inradius. This is the Inradius and the area of the triangle relationship.